Hello, I'm going to show you how to solve series and parallel circuits. Okay, so first of all, let's put a series circuit here. We'll draw the battery here. The longer end is the plus, and the shorter end is the minus. And we'll put a resistor, change that color. We'll put a resistor here. That resists the current, okay? And let's say that this battery is 100 volts, 100 V, and the resistor is, we'll make it 5 ohms, 5 ohms. And we want to know the current through this circuit. We are going to use a law called Ohm's law. Voltage equals current times resistance. Okay, so let's plug everything in. So the voltage is 100 equals the current, which is unknown, is I. Resistance is 5 times 5. To solve for I, we divide each side by 5, and that's 20. So 20 amps is the current in this circuit. This is called a series circuit because there's only one path. You're going to move, in electronic textbooks, they'll show like it from the positive to the negative terminal, but the current flow is really from the negative to the positive terminal. It's the electrons that move, these electrons in the wire itself that move. Okay, and since the electrons are negatively charged, they're going to move toward the positive end. Okay, now if you have, let's say that instead of one resistor, we have another resistor on this one. We'll add another one like here. And then we'll say that this one is 10 ohms. Okay, 10 ohms. Now, what we'll do here, we'll say that voltage equals current times resistance. Voltage is 100 equals the current. Now the resistance, we add the resistors. 10 and 5 is 15. So times 15. To solve, we just divide by 15. Now if we do that, we get the current I is equal to 6.666 repeating. Let's take it to 6.7. So 6.7 amps would be current flow through this. Okay, we call it series because there's only one way for the current path to go. There's only one path. Okay, let's look at parallel now. Parallel, let's draw. We'll put our resistors in a moment. Here's our battery, positive, negative. Put a resistor here and a resistor here. And we'll make this one a 4 ohm resistor. And we'll make this one a 6 ohm resistor. Okay. So in this case now, when current flows through it, current is going to move from the negative to the positive, but it could go this way, or it can go this way, or it can go this way here. There's two ways that it can go. Okay? There's two ways. When it gets here, it can split and go two directions. All right. Because it can go two ways, we call it a parallel circuit. Parallel circuit. And now if we want to find, let's say we want to find the current before it branches and the current after it branches, the current is going to break up. And more current's going to go through the 4 ohm resistor because there's less resistance. And unless it's going to go through the 6 ohms. So the current is going to break up, it's going to rejoin here, and the value it is here at this point is going to be the same value for the current here. So we're going to look at those points. So to get the current at those spots and along here, what we're going to do is we're going to, in parallel, you have to take the numbers 4 and 6 and place ones on top. So it'd be like 1, 4 for the top resistor plus 1, 6 for the bottom. You place a 1 on top of the 6 and 1 on top of the 4. Then what we're going to do is we're going to add these fractions. So 6 times 1 is 6 plus 1 times 4 is 4 over 6 times 4 is 24, which is equal to 10 over 24. So that's how we start. So let's add those fractions together. So we cross 6 times 1, 6, 1 times 4, 4, 6 and 4 is 10, 4 times 6, 24, 10 over 24. Now you have to flip it, and then 24 divided by 10 is 2.4. So your resistance is 2.4 ohms. Okay, so then what you're going to do is you're going to use Ohm's law again, and I forgot to put the voltage, but let's say it's 100 volts, right? It's 100 volts. So you're going to use Ohm's law, where you're going to say voltage equals current times resistance. The voltage is 100 equals the current, which is unknown, times the resistance, which is 2.4. So to solve for I, the current, divide each side by 2.4. So that gives us about 41, it's 0.6 repeating, so about 41.7 if we round it to the tens place. And that would be amps. And that would be the current at this spot and this spot. So that current's going to split as it goes through the top and bottom branches. But when they rejoin, they're going to add up to 41.7 amps. Okay, so that's how you do a pair. That's an example of how to do a parallel circuit. Okay, so I went over series, showed you how to do a series circuit. I showed you how to do a parallel circuit. All right, thank you for watching.